So you can't see that storm from miles and miles and miles away and keep yourself a safe distance, but you can see that supercell starting to rotate. I think there's some better images towards the end of this video, but I think at some point you can see the updraft. You see those?
Oh, yeah.
Yeah. I don't think this supercell, if I remember right, produced a tornado, or at least on this video, but you can see how dangerous it can be. You definitely want to stay away from it. Just to keep in another fun fact, it's not a tornado unless it touches the ground. Okay, we can have a funnel cloud underneath one of these wall clouds associated with these supercells, but it's not a tornado unless it touches the ground. So I don't know. I wish I had the sound, because I think the sound creates a... Just watching this, it could almost put you... One of those calming videos.
Are they called something special if they touch down on water?
Water spouts. So, yeah.
What do you say? Water what?
Water spouts. Yeah.
So do you watch like the thunder snow video? Stuff like that?
I've heard thunder, snow, and whatnot. I don't know if I know the video you're talking about.
You
But,
gotta get into it.
So.
It's a weatherman, and he's freaking out on camera.
Okay. Thunder snow.
Thunder snow.
Broadcast meteorologists are awesome. So you get something major happening and the weather geeks go crazy. So obviously in this case, the storm chaser felt they were a little too close, so got to go take another view from the storm a little farther out. But you can just see how massive these storms are. And the rain's coming down now. This is another case, storm chasing. You gotta know what you're doing. You don't want to get caught in rain, because there can be tornadoes that get caught up in that rain shaft, and you don't want to run into it.
Have you been storm chasing?
Yes, I haven't been out to Oklahoma and Texas. My brother lives there. I think I'm going to go at some point, but yeah. Sometimes I just want to tell you guys, even a meteorologist in 2014, I had to take shelter. So, yeah. All right, enough of that.
Can we get the volunteer hours?
Storm chasing? I cannot imagine.
See, well, I've tried to get the department to do it, but I think insurance plays a big part of it. But lastly, fog in contact with the ground. This is a stratus cloud. You guys saw that this morning. It's quarter mile or less. Doesn't meet that. Feels like a mist outside. But has to be saturated for that fog to develop. That fog develops, said earlier, clear skies, light winds, humid air at the ground. Usually in those low-lying locations, especially in eastern Kentucky. I'm sure if you lived in the valleys, you see this quite often. Those valleys cool off a lot quicker than the areas around them. But once again, when those temperatures start going up, moves away from that dew point, what happens? That fog starts to burn off. So the air isn't nearly as saturated as it was what it was whenever sunrise hit. Sometimes you have advection fog, all right? Warm air advecting over a cold surface. Now this is a little different. This isn't just the skies opening up and that radiation re-radiating back out through the atmosphere. One of these cases, warm air flowing over snow-covered ground or a cold water surface, the Great Lakes. This was the fog bowl back in 1988, all right? If you're a sports fan, I'm a huge sports fan along with a weather geek. The two came together during this event. I was born in '88, so I don't remember it, but it was interesting watching this video. I'm sure some of you guys watch football. I don't know if any of you guys have heard of this event, but This is what it was like. Like during this event. So they still played the game. I think it was a 10-6 ball game. I can't remember who won, but this video goes over it. You can see, it's hard to say this is a 4-minute video. At one point, I encourage you guys to all watch this. It's something to see, but if you're up at the broadcaster's box and you were looking down at the field, you just saw it there, you don't see the game. And so my question, so there's the broadcaster's view. They had a fun job that day. But even during I haven't looked at this.
Following each other.
I haven't looked at the statistics, but I just wondered how many passing yards there were that game. But I remember part of this video they were talking and saying, you know, you run down the field and you think you're wide open and whatnot, and then bam, you're taking a hit to the back. So, but so fun weather game. There's a referee. You had to have audio or nobody knew what was going on, what the flag was for. These were the broadcasters. There's their view of the field. So they had a great time.
I bet everybody paid for a ticket was just really tough.
Oh man, I wouldn't have liked it. So we want a refund. Yeah, I wonder how many people got injured. But yeah, so that's the Fog Bowl in 1998. Now you guys learned something.
I gotcha.
All right, let's talk about where we get this, where we can see cloud cover. We use satellite data, one of two. Usually it's these geostationary orbits rotating Earth. They stay in the same location, taking a constant picture as the Earth rotates. So it's rotating with the Earth. I won't spend a whole lot of time on this other than we did have a new satellite go up recently, last year. It's operational now. Very high resolution. This is one of the pictures. I thought this was super cool, getting the moon in the image with Earth. But you can see all that cloud cover across the atmosphere, but much higher resolution. You can see lightning on this satellite imagery. This was Hurricane, you guys remember this? Just happened. Florence. So this is an image of Florence hitting North Carolina, southern North Carolina there. So very high resolution imagery. I mean, you can pick out the rain bands. One's actually decently close to eastern Kentucky at that point. All right. Yeah. This is out in California. What do you guys see here? What do you see here? See some fire, see some smoke. So this satellite imagery is such high resolution, it can pick up on these smoke plumes. Really helping out with fire weather nowadays. GOES lightning imagery, this is brand new. So you see the cloud cover, you see the storms associated with that cloud cover as they're progressing across the Ohio Valley, out in the Great Plains region, so on and so forth. So this is light years ahead of where we were. So very impressive stuff. Different types of satellite imagery, visible, black and white. You guys can see the cloud cover here, sunlight reflecting off the clouds. You guys don't see anything across the western half of the United States. Does that mean there's no cloud cover? No. That just means the sun hasn't came up over there. All right. So we need the sun to reflect off the clouds so we can see it. So sometimes overnight, we don't have the sun, so we have to rely on something called infrared satellite imagery. We're looking at temperature comparisons out there. The higher clouds, as we talked earlier, colder. You get lower in the atmosphere, warmer. You can see some of the higher cloud tops across the eastern seaboard there with this infrared imagery. We're pretty clear here in Kentucky at this time, maybe some warmer lower clouds out there in eastern Kentucky. Excuse me, eastern Kentucky. Water vapor imagery, another thing we get from satellite data. We're seeing where those higher level of moisture, higher areas of moisture are across the United States. I think this was the same image. Higher moisture across the eastern seaboard, drier air, this brownish color going across the southern part of the United States.
So when it's raining, this like the clouds are actually lifting? When it's cool, I mean, it's dropping water, obviously.
Yeah.
It's getting cooler.
You got air rising. As that air rises, it cools, and eventually that humidity we talk about reaches saturation, and we have clouds form, and sometimes you get precipitation. I will tell you guys, most clouds don't have any precipitation. So lastly, types of precipitation. I won't spend much time on this. Rain, you guys all know what rain is. Drizzle, you all know what drizzle is, all right? Drizzle, you're typically seeing from those stratus clouds I was talking about earlier. That light to moderate precipitation, good bet you're gonna see some drizzle. This is one of those cloudy fall days here in Kentucky. You just wanna stay indoors and eat chili. Snow is a little bit more complex. Snow, the shape of snow, so on and so forth, what it's made out of, it varies dependent on temperature outside. And depending on what type of snow you get, just for instance, these dendrites, that's those cool snowflakes that you see outside every once in a while. Sometimes your kids will make those paper snowflakes or whatnot. This is what they're going off of. But that's not what all snow looks like. So sometimes you have plates and columns. The colder you get in the atmosphere, these are your very high accumulating snowfall totals we see across the United States. And sometimes you have something as small as needles. You don't have much accumulation to these. So colder it gets, the higher accumulation you're going to see. I guess that's the takeaway from here. Ice pellets, otherwise called sleet. I'll show you guys, I want to show you guys a graph here in the next to really explain it to you. But snowflakes are basically ice crystal snowflakes that partially melt through the atmosphere. They get to the lower levels and they refreeze. And freezing rain, those ice crystal snowflakes have completely melted through the atmosphere. They fall to the surface where it's below freezing, and they freeze on contact to objects across the area, trees, roads, power lines, so on and so forth. And then hail, once again, you get stuck in those strong updrafts and those cumulonimbus clouds, and can grow different sizes of hail. We were talking about, you know, the impacts of hail hitting somebody. I'm not sure about fatalities, but this was a record-setting hailstone, South Dakota, July 23rd, 2010, 8 inches in diameter. So, and I tell the class every year, it's 8 inches in diameter right now. Well, there is a time a person took to find that hailstone and get that back to their freezer or whatnot to preserve it. So I'm sure there was some melting that occurred, but 8 inches in diameter is, that hits you in the head, I don't know. But this is a cross section, how precipitation falls through the atmosphere according to temperature. If the column through the atmosphere, it's more than just looking at the surface of meteorology. We got to look all the way up through the atmosphere, the troposphere at that. And if it's warm above 0 degrees Celsius, above freezing, throughout the column of the atmosphere, it's going to fall as rain. Those snow is going to melt and fall through the atmosphere, hit us as liquid precipitation. Sometimes it starts out as snowflakes. There's a large layer of the atmosphere that's above freezing. It completely melts. and sometimes it's cooler at the surface, all right? Sometimes it's actually warmer above us than it is here at the surface. And if it gets down to the surface and it's below freezing, it hits those trees, power lines, cars, and it freezes on contact. You get freezing rain. Sleet, a little different. Snowflakes, a smaller layer of the atmosphere is warmer, not as substantial of a trunk, or maybe it's warm but not as substantially warm as times of freezing rain. But then it gets to the surface, it refreezes, and you start hearing that click, 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 click on your windshield, on the surface, and it can accumulate in some instances. And then you go opposite of rain, it's below freezing through the entire column, it's going to fall snow to the surface. So this gives meteorologists a lot of trouble during winter weather events. Typically, you're adjusting snowfall totals all the way to the start of the event based on new forecast model input coming out, based on temperatures outside, so on and so forth. And so whenever you're watching the newscast and you see a week out that we're supposed to get 15 inches of snow, I wouldn't put a lot into that. So wait till you get a little closer. 1 or 2 days out, we're generally in the ballpark, but that'll narrow itself down as the event's occurring, so on. So Virga, most clouds do not precipitate. Virga, you look out in the atmosphere, you might see what looks like rain falling from the clouds, and that's probably the case. But it hits a dry layer at the surface and evaporates, so we don't get any accumulation at the surface. Measuring precipitation. This is an example out at the Woodford County Farm. This is a weighing rain gauge. Rainfall, precipitation accumulates in this white cylinder. There's a bucket in here. During the winter months, it actually melts. There's a heated ring in here. Melts that precipitation, goes into the sensor or the weighing bucket, outputs how much precipitation we got. You guys see these I'll just say metal shield around the rain gauge. You're actually trying to stop that wind or anything from impacting your precipitation measurements in that area. Something you guys will more than likely see out in the field is these tipping bucket rain gauges. These are much more readily available, but as precipitation falls into this funnel, every 100th of an inch lands into this what we call tipping bucket. There's a bucket on each side. Once 100th of an inch accumulates, it dumps that water out, starts accumulating the other side, that dumps out, keeps going back and forth during the rainfall event. And then lastly, this is the CoCoRaHS rain gauge, Community Collaborative Rainfall, Hail, and Snow Network. This is a volunteer network, and I really encourage everyone in here to get a rain gauge if they can, put it up in their hometown, or maybe once you get out of school. But they're about $30. It's not associated with the National Weather Service, but another organization. We were talking last night, really helps out in flash flood situations because rain gauges are relatively sparse across the United States. Sometimes there's problems with research because there's not a rain gauge within 10 to 20 miles of your research location. And you get in the summer months, what happens?
Popcorn storms.
A lot of popcorn storms, right? So these popcorn storms, the northern part of the county might get 2 inches of rainfall. Southern part of the county might not get anything. So sometimes it's useful, if you're really interested, just put up one of these rain gauges, get information at your research location. So plus you can input this data daily to the National Weather Service, or I'm sorry, the CoCoRaHS website, and helps a number of people out other than just yourself. So this is a map of all the CoCoRaHS observers across the United States. This is a current map as of October 2nd. You can see in Kentucky, there are still several locations across the state where we don't have any observers. So tell everybody, the more data you got, the better. So if you can get a Cocoa Raw's rain cage, that'd be awesome. Sea precipitation. We use radar. It can either be in reflectivity mode. You guys see this on the 6 p.m. newscast every night. You probably have it on your phone, Weather Channel app or some other app. Looking at the location, movement, intensity of areas of precipitation across the area. There's multiple radars across Kentucky. Once again, you can either see that reflectivity, the precipitation falling, the intensity of that precipitation falling, or it can go into Doppler mode. You probably haven't seen this, but this is where you can see circulation on the radar. Now I got 3 different links here, just showing you some radar imagery associated with some of the tornado outbreaks. But this is 2012 radar reflective imagery. Here's that hook echo going through West Liberty. I think that was a EF3 tornado. Here comes another one through Salyersville, hook echo through there. These higher values, purple and red, very heavy rainfall, intense rainfall. You get into this greener shades, yellow shades, lighter to moderate. This is that velocity mode. Once again, you get green and red right next to each other. Tornado or possible tornado. You're more than likely getting a warning. Here comes, I guess it just went by. Red and green right next to each other. So there's that. Going back to the PowerPoint real quick, click the next one. 2012 Joplin tornado. Or I'm sorry, I guess I put the wrong link here. This is from the West Liberty tornado, but I just wanted to put this in here to go along with the radars. You can see the power of a tornado passing through the area. This is a surveillance video on the side of a house, and the reason why you don't want to be outside during an event like this car was getting kind of bumpy too. But trees uprooted, tornado passed through. You can see the debris going across the area. Piece of, yeah. But I tell everybody, it's all about the debris flying every which way with these tornadoes.
That house fall apart.
Wow.
Man, I'm surprised it survived.
Oh, they're going over the gutter.
And then, I said earlier, these tornadoes don't, I mean, they move through fast for the most part.
It's shielded by the house.
But there's another, there's different angles here. Yeah, you just saw it. You can see that garage door just be ripped out. And that's why you don't want to stand near doors or windows when there's a tornado going by. But you can see the trees start to fall in the background. And yeah, so.
If you're on the highway and there's nothing nearby, are you supposed to go under your car?
Under what?
Your car.
So first off, don't ever go under overpass to take shelter. Because if you go under an overpass, the winds are just maximized under that overpass. So I see people that take shelter, absolute wrong thing to do under overpass. I'm going to tell you, if you're in a car and you see a tornado, if it's me, I'm gone. There's our son, you know, try to get to the lowest lying location, a ditch or something, but I'm trying to get away from it. So you guys can see the amount of debris that's being lifted in these situations. So, but hopefully if there's a tornado watch, you know there's the possibility of tornadoes. So, yeah, so, all right. And then lastly with radar, Sometimes it's in clear air mode. You might see what looks like precipitation across the area. That's not the case. You might look outside, it's clear skies. Especially during this time of year, you can start picking up dust particles, bugs across the area. Sometimes you'll see birds. You'll see little specks of reflectivity on radar. Sometimes you have ground clutter reflecting back. But I wanted to show you guys this little link here. I know I'm kind of giving up the what's going to happen, but so this is a picture of radar up in Wisconsin and La Crosse, I guess. But you look at this radar picture, what do you see? You typically look at radar. What are you thinking right now? Light to moderate precipitation or whatnot? Yeah, that's not the case. Mayflies.
That's disgusting.
Hey, you want to get gas tonight?
Jesus Christ.
That's gross.
So, and I'm not an expert in entomology and whatnot, but I thought I read someplace. Someone correct me if I'm wrong if you're in entomology. I think the lifespan of these mayflies are like less like hours.
Ephemeral was literally in their Latin name.
Do what?
Ephemeroptera, they're ephemeral.
Okay. So, just that's over my head.
What does that mean?
Ephemeral, like, doesn't
Short.
last long.
All right, bring it all together, different weather stations across the area. We got these ASOS stations at the airport. These are pretty high complex. You won't see these. You won't have clearance to go see these for the most part. But aviation, once again, got to keep you guys safe. These are the Cooperative Observer Network. Typically, you're just getting temperature readings and you're getting this is a tipping bucket rain gauge right there. So getting a precipitation measurement. Very simple.